Hello guys and welcome back. Today we're going to be solving question number 59 on Leetcode. This is a spiral matrix number 2. It is a medium problem and we're just going to go through how to solve it. So here's the question. It says, given a positive integer n, generate an n by n matrix filled with elements from 1 to n squared in a spiral order. And we're given an example here, example number 1, where the input n is equal to 3. So since n squared is equal to 9 in this case, you will get a range of elements ranging from 1 to 9. And as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. You can also see that the elements are being filled in a clockwise manner. That's a good thing to note as well. And then example number 2 says the input n is equal to 1. So since 1 squared is equal to 1, you only get one element in the output, which is 1. We're also given constraints that say that n is ranging from 1 to 20 inclusive. So you can expect to get a maximum number of elements as 400 in this case. So the first thing to do in this kind of a question is to try to understand it further on your own. So typically, if it were me, I would try to go through an example of my own. So in this case, we're going to go through an example where the size of n is equal to 4. So for our example where n is equal to 4, it's going to be a 4 by 4 matrix, and the range of numbers is going to be from 1 to 16, which is 4 squared. So what we want to do is we want to actually write our code by looking at this example. So we're going to go back to Leetcode and start writing some code. Leetcode. So for this problem, I'm going to make a helper function called fill matrix, which is going to help us solve this problem. This fill matrix function is going to be void. It is going to take in the vector and fill it in a clockwise fashion. So let's write it down. Void fill matrix is going to be taking in the vector. We just call it matrix to make things simple. And as you can see here on the left, that we're filling in this matrix in a clockwise fashion like this. So we start from the first row to the last column here. On the first row, start from column number 0 to column number n-1. So we're just going to be translating all these movements directly into code. So, but for us to be able to do that, we need to give this function arguments that make it know where to start and where to end. So we pass in the argument that tells us which row to start with. Call it row start. Also pass in where to end for the rows, row end. And then for the columns, we pass in column to start with. Let me skip a line so that you guys can see all the arguments. Then int column, and we're also going to pass in a number that we're going to call n. This number here is going to be what we'll be using to fill in this matrix dynamically. So if you don't get this, do not worry. When you start filling in the body of the function, you understand how this works together. So now let's start the translation. Since for this function you have to fill in the first row first, let's make a for loop that iterates from the first column to the last column. So since the columns are changing, for int I is going to be starting from the first column, and then I should go up to the last column, I plus plus, and what we are filling in is basically, you know, these numbers here, which are in these columns in the first row. So you say matrix, and then the column that you want to fill in is the one that is going to be indicated by I. So the row will be the first row, which is row start. And then here we initialize to I, and then that's going to be equal to k plus plus, since the number is going to be increasing. And then after this code, we've managed to fill in this first row. So now we are going to be going down, which means we are starting from the row that comes after row start, and then the rows will be changing, but the column will be the same. So into code, that becomes for int I is equal to, since the rows are changing and the rows are starting from the row that comes after the first row, you initialize this to row start plus 1. Row start plus 1. And then this goes up to row end. Then I plus plus. So you say we're filling in the matrix at I. And then for the column is the last column, which is column end. and that is equal to k plus plus, like this. And then for the third sweeping motion, which is starting from here, which is n minus 2, or the column that is just before the column end, the columns are going to be changing in this last row to the first column. So put that into code, it becomes 4 int I is equal to here, which is column n minus 1, column n minus 1, and I is supposed to be greater than or equal to column start, and then I minus minus, because it's decreasing, and then we say matrix, and then for the row is the row end, and as for the column, that's I because it's changing, is equal to k plus plus. And then for the last sweeping motion, we're starting from the row that is just above this last row. So in code, that's for int I is equal to, for int I is equal to row end minus 1, and I should be greater than. So note that in this case, we're not going to say greater than or equal to, because we cannot refill in this value here. That will be overwriting a value, and that will be wrong. So up to I is greater than row start. So the first row is not going to be filled in, and then I minus minus, we fill in the matrix. So we say matrix, and we say for the row it's going to be I, and the column is basically the first column. Column start is equal to k plus plus. So after doing this, you've practically managed to translate all these sweeping motions into code, but you haven't managed to fill in all the positions in this matrix. So that's where the recursion comes in. So you're now going to call that function again. So you're going to say call fill matrix with the same matrix that we passed in. Remember, we said we passed in by reference, so here we're supposed to put in an ampersand. I hope some of you noticed that. And then we put in the matrix, and then as for the row start, it's now row start plus 1, because the first row that we're using in this function has been used already. So that's row start plus 1. And then for the row end, it's row end minus 1. Then call start plus 1. And this is supposed to be commas, not semicolons. So comma, and then call start plus 1, and then column end minus 1, and then k, like this, because k is continuously increasing starting from 1. And then since this is recursion, we need a base case, which is basically going to make sure that this function ends, and that's going to happen when column start becomes greater than column end, or row start becomes more than row end. So you're going to put an if statement here. If let's start with the row. If row start is greater than row end, or column start is greater than column end, we want to return. So this is our base case, like this. So what we're going to do in this other main function is that we're just going to declare our vector that we're going to be using in these operations. So let's just call it a vector. We can call it matrix as well, or any other thing. Let's just call it solution, because this is our solution. So actually, let's just call it matrix. Okay. And then it's going to be of size n, right? And then n, since it's a two-dimensional vector, and vector int of size n, you just put zeros here for all the numbers, and then we want to fill it in. So we call fill matrix, and then we pass in that matrix that we just declared, and then we pass in row start, which is going to be 0, and then row end is going to be the number here, since it's n by n matrix, so row end becomes n minus 1. Same for the columns, 0 and n minus 1. And then we pass in 1 for the value of k to start with. And then after that, after filling in the matrix, we just return it. So we return matrix like this. Right. So let's see if we made any mistakes. Let's run for the basic test case. So here, okay, yeah, another semicolon that we forgot to remove. So let's make sure there are no other semicolons in the declaration of arguments. Okay, I think we should be fine now. Okay, accepted. So let's just maximize the screen so that we can submit this solution and see if it passes all the test cases. So submit. Right, been accepted. Let's remove full screen here. So you can see it has been accepted with faster than 100%. We can just submit again just in case, you know, you didn't see that. Right, accepted, faster than 100%, and memory is also small. So this is how you solve a matrix number 2 problem on Leetcode. Thank you, and see you in the next video. Please don't forget to like and subscribe for more videos like this.